Click and learn CXC Dynamic Math Self-Study Guides. You can understand circle theorems by exploration, experimentation, by observation, by making inferences and forming a conjecture and proving if your conjecture is either right or wrong. In this lesson, we look at Theorem 2, Circle Theorem 2. Now the first thing, we'll use our powers of observation to observe this diagram closely. We see a circle and we see a line drawn from point F on the circumference of the circle through the center of the circle to another point D on the circumference of the circle. Now since the line passes through the center of the circle, that line is a diameter of the circle. So FD is a diameter of the circle. We also observe that another line is drawn from point D on the circumference of the circle to point G to another point on the circumference of the circle. So we know that DG is a chord. Similarly, a line drawn from point F on the circumference of the circle to another point, to the point G on the circumference of the circle, is another chord, FG. And at their intersection they form an angle. So what we are curious about is, what is the value of this angle here? We want to know the value of this angle. Well, we know, for example, that at this center of this circle here, at this point here, we have a straight angle. That's one. So we have this straight angle here, then we have another. Okay, so we know that this straight angle is equal to 180 degrees, and we know that this other straight angle here is equal to 180 degrees. We also know that the angle at the point is 360 degrees. So since this angle here, let me see if I can, we also want, okay, so we know the sum of the interior angles of a triangle add up to 180 degrees. We know that equal to 180 degrees. The interior angles of a triangle, this angle plus this angle plus this angle, is equal to 180 degrees. So what we want to do now, we want to draw a line from this point to this point. But let's remove those markers first. You want to draw a line from this point, the center of the circle, to this point here. And we realize that this point here from E to D is the radius of the circle. And this point here from E to G is also a radius of the circle, because it starts from the center of the circle and goes to a point on the circumference of the circle. So we can say that this side here is equal to this side here. Why? Because they are radii of the same circle. Likewise, EG is radii of the same circle too. Now, what can we conclude from that? We can say that triangle EDG is an isosceles triangle. Triangle EDG is an isosceles triangle. So let's examine the angles here. The angle, the base of the triangle, this angle here would be equal to this angle. Why? Because it's the basis, it's the base angles of an isosceles triangle. You have one side equal, this side here equal to this side here. So this angle here is equal to this angle here. So let's measure each angle and see this angle here. And we see it's 34 degrees. Let's measure this angle here. And we see it's also 34 degrees. These two angles are equal. Now let's measure this angle here. And this angle here. Now this angle here would be equal to this angle here because EFG is also an isosceles triangle, because EF is equal to EG. So let's measure this angle. See, it's 53 degrees. And this angle here is 53 degrees. This is 53 and this is 37. When you add up, they're 90 degrees. So we can say now, this angle plus angle, this angle here is equal to 90 degrees. So we can say that the angle in a semicircle, the angle in a semicircle is 90 degrees. This angle here is 90 degrees. Now let's see if what happens when we move this point here anywhere on the circumference of the circle. Does the angle change? While the lengths of the chords change dynamically and the angles change, when you add them up, 56 and 34 remains, gives you the same sum. 56 and 34 is 90 degrees. The angle in the semicircle is 90 degrees. So by observation and by measurement, we have shown that the angle in a semicircle is 90 degrees. Now, it should be noted that this is a special case of Theorem 1, with the center angle being 180 degrees.